Alright, this video is going to give you a brief rundown of our third orbital parameter, which is the inclination. Now, the inclination right now is set at 25 degrees inclination, and that basically tilts my orbit up north and south. To give a good contrast, let's go with a couple of standard settings. An inclination of 0 degrees is actually an orbit that stays above the equator the entire time. So that's what we call an equatorial orbit at 0 degrees. Or you can tilt it up 90 degrees. Let's go with a 90-degree orbit. This is called a polar orbit, where the satellite goes basically north-south the entire time. Now remember, the Earth actually rotates underneath it, so it's not always going directly north and south from our ground track viewpoint. It kind of shifts to one side. That's because the Earth is actually moving. Now, a lot of times you'll want something maybe in between, maybe 45 degrees. That's a nice diagonal cut on this. One thing that I will point out, you can actually go above 90 degrees. Let's go 110 degrees. Now, when you do that, it kind of cycles back over where this would be kind of the same type of angle, more or less, as something in the, 70s. But when you're above 90 degrees, that's what we call a retrograde orbit, and it means that your satellite is actually kind of going the opposite direction of the Earth. So for instance, let's compare this: an orbital inclination of 0, and when I press play, we can see that the satellite is moving from left to right, at least when it's in front here, basically going the same direction as the Earth. Let's go ahead and set ourselves up an insane retrograde orbit, 180 degrees, which looks like an equatorial orbit, but watch. Now the satellite moves from right to left. It's going the opposite direction of the Earth. Now, you do have to pay close attention to whatever your limitations are on your particular scenario. Many times it's very hard to get a retrograde orbit. It requires a lot more fuel, so you'll end up with limitations. Check our specifications to see if that applies here. The last thing that I'm going to point out on this is your inclination. Let's go back to kind of a regular value for that. I don't know, 30 degrees. Nice diagonal cut here. You can see here on the 2D ground track that 30 degrees is my orbital inclination, and we end up with the satellite, the top of the bump basically touches the 30-degree latitude in the north and negative 30 down in the south. So basically, let's check this out. Let's go to 60 instead. When I do that, we can see that it updates and the bump goes up to 60 degrees for both of them. So in short, the inclination, changing that, allows your satellite to move more north and south so it can see things higher in the northern hemisphere or lower in the southern hemisphere. So that's a great way to keep track of inclination, and it has a big effect on the types of orbits that you actually set up.